Hello everyone, this is Mary and you're watching Comparing RL Algorithms in Pong game. It is a project done in the Introduction to AI class taught by Dr. Vahid Behzadan. The teammates are Amirhossein Karimi and Mary Narouei. Let's start with a quick introduction of the Pong game. Pong is a two-dimensional game that simulates table tennis. The player controls an in-game paddle by moving it vertically across the screen. In the field of deep RL, many algorithms have been developed with distinct advantages. However, finding the most effective algorithm for specific environments is a challenge. This project aims to evaluate three widely used algorithms by testing them in a Pong game. For this study, we have selected proximal policy optimization, deep Q network, advantage actor critic. We are using RL Baseline 3 Zoo repository, and our primary tool is Jupyter Notebook. In this video, you will see a step-by-step implementation instruction for training and evaluating an RL agent in Pong environment using our algorithms. After getting the results in a CSV file, we will use the data to plot a reward steps diagram for each algorithm, and by comparing them, we will get the following performance metrics.
So to train our agent, first we have to clone our repository, which we are using this repository RL baseline 3-zoo. You can find the documentation here. It shows the step-by-step installation process. First we have to clone this repository, then install the requirements. After that you can train your agent. So we trained our agents, all of them, for 10 million time steps. For this amount of computation, you need a GPU. So you can use your own GPU or you can use Google Colab. Okay, this is our training for PPO. Before training, you have to define and create a hyperparameter file. This is our hyperparameter file. As you can see, we train our agent for 10 million time steps. The same for A to C and the same time steps for DQN, so that we can compare them together. You can use the default hyperparameters defined in the repository, or you can change one or some of the values. After this is the this is the code for training the agent using PPO algorithm in Pong environment. After training our agent, the results will be saved in a .csv file. So we loaded our results. These are the last rows of this file. As you can see, it has 3 columns: reward, episode length, and time step. So we plotted our results. As you can see, we have 2 types of plots, the average reward and the average episode length. Why we are using average? Because we are averaging over 50 episodes, the rewards of 50 episodes, so that we have a smoother plot. After that, we evaluated our agent for 10,000 time steps. So as you can see, for PPO we are getting the full score in all the episodes. After that, we are recording a video of our trained agent using this line of code for 1,000 time steps. You can show it. You can see it here. As you can see, it's getting the full score. The same process goes for A to C and DQN. I just show the evaluation part. So as you can see, in A to C we are not getting the full score. So it is not as good as PPO. Also in DQN we are getting better results than A to C, but again not as good as PPO. We are comparing all of our results in this file. So PPO has the best performance. It increased, the rewards increased sooner and sharper than the other two algorithms, and the final rewards are higher than DQN and A2C. DQN is higher than A2C, but it is very noisy. The episode lengths of PPO, again, we can see that the final episode lengths are lower than the other two algorithms. After that, DQN and PPO. DQN has a peak during the training in episode lengths. So finally, we just calculated the mean of rewards and episode lengths all over the training. So again, you can see that PPO has the highest reward during the training, the highest mean reward during the training. After that, DQN, and after that, A2C. For the episode lengths, A2C has the lowest episode length, lowest mean episode length, and after PPO, after that, DQN. That's why A2C finishes sooner than PPO and DQN, because it has the lowest mean episode length over the training, so it finishes sooner than the other two.